Okay, good morning, everybody. Thursday, hey, and then Thanksgiving next week, whatever that means. Anyway, 11:19. So today's lesson's pretty easy. It's kind of nice that we've moved away from a lot of algebra into geometry, because geometry is so much easier than algebra, and that's why we don't do a lot of geometry, because you already know it. Anyway, let's talk today about triangle mid-segment, okay? Today's objective is a triangle mid-segment. Okay. We just draw a picture so you see what a triangle mid-segment is. Okay, and then we'll define it. So if you draw, whoops, throwing things around. Okay. So let me draw a triangle, okay? Just any old triangle. It could be any triangle at all. Just make it nothing special, nothing fancy. Okay. So easy day today, okay? So mid-segment. So mid-segment means basically the midpoint. Midpoint of a side. Okay, so midpoint, mid-segment. If I were to measure, let's see here. Golly, let me measure. See if I can get a decent ruler. Hold on. All right, there you go. I got a decent ruler. So if I were to measure mid-segment, right? Oh, that's about 4.4. Half 4.4 is about 2.2. So 2.2 is right about there. Okay, that's a mid-segment. Let's call this triangle A, B, C. So I've got triangle ABC. That's a midpoint. Let's call that, how about M for midpoint, huh? M. Let's measure this side. Okay, that's about, maybe, I'm guessing about 3.6. That's about 1.8. Right about there. Okay, let's call that, there's my mid-segment. Let's call that N, okay? So I've got a two midpoints of a side. Now the segment is this line segment. Okay, there it is. Okay, so the mid-segment is the segment. It's the segment joining the midpoints of the side. Wouldn't it be nice if I had nice beautiful handwriting? I try every year. So here's the math thing. It's going to be half. So the length of MN, or the length of MN is equal to 1/2 the length of AC. Or the mid-segment is 1/2 the base. Or in words, the mid-segment is half the base. Okay, that's pretty easy. So that means this length should be half of this. So I'm just going to measure. Check it out. Let's see, that's about maybe 3.8, and this should be a 1.9. Wow, I think that'd be pretty good. 3.8. So I just measured. I got 3.8, and I got 1.9. I just measured it. It actually worked, didn't it? So we also know something else that I think is important to write down there, and that if it is a mid-segment, we know the length of this side is equal to the length of this side, because it's a midpoint, right? So that means that I also can write that BM is congruent to MC, and I know that this piece is equal to this piece because it's a midpoint, right? So I can also say then that BN is congruent to AN. There you go. Now congruent is just a symbol in geometry. Congruent, I'll write it down. Congruent looks like this. It just shows that two things are equal. We don't say that objects are equal. We say objects are congruent. Okay, this talks about this object, this line segment is equal to this object, this line segment. We use the term congruent. Okay, so let's take a look at this example 1. Let's see if we can find a mid-segment. So let me graph. Okay, so I'm going to graph -1, -6, 1, 2, 3, 4, 5, 6, and 1. There's A. And a -2, 5. 1, 2, 3, 4, 5. There's B. And a 2, -1. There's C. Okay, let me connect the dots. I make my triangle in blue so we can see it better. Okay, there's triangle ABC. Okay. And let's see if I can find the mid-segments. Well, the mid-segments aren't too hard because I can just count. Okay, I'm pretty sure that's the mid-segment there. I can count 1, 2, 3, 4, 1, 2, 3, 4. So 4 and 4, let's go up 2 to 2. Okay, that's mid-segment. Let's find this mid-segment here. Let's see, 1, 2, 3, 4, 5, 6, 1, 2, 3, 4. So up 3 over 2, mid-segment's right about there. Now if I connect those dots, all right, that's my mid-segment. Okay, let's just call that MN. Now, one of the things I want to do also, because there's one more thing we haven't talked about, and that is the fact that if we look at their slopes, okay? So look at the slopes. If I look at the slope of AC, and if I also look at the slope of MN, okay? Slopes. AC, all right? Slope is rise or run. Hopefully remembers that slope is rise over run. Okay, hopefully you remember slope is rise over run. So if I'm going to go from A to C, I'm going to have to go down 1, 2 over 1, 2, 3, 4, 5, 6, 7, 8. So I went down 2 over 8. Well, that would just reduce, right? If I reduce that, reduce to a -1/4, which is down 1 over 1, 2, 3, 4, down 1 over 4. Yeah. Now what about the slope of MN? Slope of MM, let's see. Down 1 over 1, 2, 3, 4, down 1 over 4. Okay, so what do we know? So if the slopes are the same, we know they're parallel. So I'm going to write that down. I know that they're also, the mid-segments are also parallel. So the base is parallel to the mid-segment. Okay, there we go. So I can say that MN is parallel to AC because the same slope, okay? So I did the slope. Slopes were -1/4 and also -1/4. Now the lengths, if I did just a little bit of quick right triangle trig, let's see, right? Pythagoras Theorem, but if I did 1, so a squared plus b squared equals c squared, right? And I'm going to show you how I do this. Check this out. Okay, you see a little mini right triangle right in here? If I want to find the length, I'm just going to use Pythagoras Theorem. It's the easiest way to do it. So if I want the length of MN, I'm going to set up a squared plus b squared equals c squared. So I'm going to go 1, 1, 2, 3, 4. So I'm going to go 1 squared plus 4 squared equals c squared. Oh, so sorry, you guys. You can't see anything if I do it that way. Now you can see it. So I get a 1 plus a 16 equals a c squared. I get 17 equals c squared, or the square root of 17. Okay, that's the length of MN. Now what about the length of AC? If I do the same thing, again, I'm just using Pythagoras Theorem. It's the easiest way to find the length. Okay, see triangle right in here? It's my triangle. I should use a different color. I'm running out of colors, though. Oh, here we go. Here we go. So, again, Pythagoras Theorem, I've got 1, 2, 1, 2, 3, 4, 5, 6, 7, 8. If I go 2 squared plus 8 squared equals c squared, 4 plus 64 equals c squared, I get 68 equals c squared, which is the square root of 68. Now that can be broken down. 68 is the same thing as the square root of 4 and the square root of 17, which the square root of 4 is 2, so we get 2 square root of 17. Now if I compare the lengths, sure enough, this one, the base, is twice as long as the mid-segment. Well, we knew that, right? We knew that. If we go back up to here, we just proved it again. We know that the mid-segment is half the base. Okay, we knew that, okay? So, let's take a look at the next page. If I get going too fast, you guys, you can always pause the video. You know that, okay? So, let's look at the next page. Okay, so here we go. These are mid-segments, so I know mid-segments. So this is what I know. I know that this side is equal to this side. This side is equal to this side, right? And believe it or not, I've got this whole side here is half of that. So let's see. LU is this. LU is 2x minus 10. And VW is right here, is an 8 minus x, okay? Find LM, okay? LM is all of this. So LM is also a 2x minus 10. Has to be. If this is 2x minus 10, then mu, and if I want LM, LM is equal to a 4x minus 20, right? Double that. And that's equal to, well, it's going to be half of my 8 minus x. Okay, one more time. This length is twice as big as this. So if I take half of this, then they'll be equal. So let's see, half of that, I got a 2x minus 10 is equal to 8 minus x. I'm just going to solve for x. I can do that. Plus x, I get a 3x minus 10 equals an 8, right? I'm going to go plus 10, I get a 3x equals 18, x equals 6. Now if x equals 6, what am I going to do with that? Well, I'm going to plug it in. Okay, put 6 right here. This side is 2. Okay, if I put 6 right in here, I'll get 12 minus 10. This is 2 plus 2, so this side is 4, okay? All right. So if this side is 4, right? And this is 2, right? I don't think we want to do the perimeter. We don't know enough information. But anyway, there it is, okay? We found LM. Okay, down to the last one. Oh, that's perimeter of that one. No wonder. Sorry, my bad. Early morning. So, here we go. We can get this pretty easily, the perimeter. So, the perimeter of this, of the little triangle. So, if this is 26, this is 26, this is 13. Okay? This is 90, this is 45. And if this is 76, what's half of 76? Half of 76, we should go do that. 35, 38, right? Yeah, 38. So all I did is I took half of that mid-segment, half of 90 mid-segment, half of 26 mid-segment, and then I'm just going to go perimeter is equal to my 45 plus my 38 plus my 13, and I'll just use my calculator to do that. Go my 45 plus my 38 plus my 13. I get a grand answer of, no, not that. Try it again. 45 plus 38 plus 13. I get a grand answer of 96 as the perimeter. Okay, so there you go. And today's homework is basically working with the mid-segment. Get your homework done, okay? Don't be lazy. And that's all I have. I'll see everybody in Zoom.